All right, this is geometry, chapter 12, lesson 3, central angles and arcs. We're going to talk about arcs first. What in the world is an arc? It's part of the circumference of a circle, right? What is an arc? It's part of the circumference of a circle. So we can measure arcs two ways: length or angle. Two ways to measure arcs. There are different types of arcs. There's a minor arc, usually indicated. Let me draw a circle. I really didn't do a very good job of drawing circles this morning. All right. All right, so a minor arc would be from A to B. How would that look? It would be A, B, and like a little one piece of the rainbow over it. A minor arc. A minor arc is any piece of the arc that's less than 180 degrees. Less than 180 degrees, or less than halfway around. All right? There's a semicircle. I should move C over just a little bit. Semicircle. A semicircle is half of a circle. So because I see that AC is a diameter, because it contains the center, then we would have semicircle ABC. I could have written ADC is a semicircle. So it is always equal to 180 degrees. Or we can have a major arc. That's greater than 180 degrees is a major arc. Anything greater than 180 degrees. With a major arc, you will always use 3 letters, always, to notate the arc. So maybe ACD would be a major arc. That means we go A around towards C and then to D. I also could have said ADB. ADB would go from A around to D and then up to B. Does that make sense? Between a major and a minor arc. All right, so I'm going to tie this into angles. If I were just looking for the length of arc AB, well, let's do that in a minute. Let's talk about central angles. A central angle is an angle in a circle whose vertices lies at the center of the circle. The vertex is the center of the circle, and the rays intercept the arc of the circle. The rays of it intercept the arc of the circle. All right, so if I went from the center to B. And let's label the center X, not O. Let's label the center X. Yes?
So intersecting just means like it splits into two equal parts?
Means it touches it.
Touch.
All right, so look, here's an angle. We're going to label the angle theta. All right? So really, theta represents angle AXB. And that angle is a central angle because its endpoints lie on the circle. That means it intercepts it. And the center, the vertices X, is at the center of the circle. Make sense so far? All right, you got this? Okay, there is a connection between central angles and the arc to which it intercepts. All right, so let's look at this. I'm also going to draw a line to D. All right, look at all the different angles I have. I have angle AOB, angle AXB. Now I'm wanting to call it O. Angle AXB, do you see that? Do you see angle AXC? Does everybody see angle AXC? What is the measure of angle AXC? Yeah, David?
It's 180 degrees.
So 180 degrees is the measure of that. Okay, now let's tie it in. What is the degree measure of arc ABC? Yes, Selby? It's 180 degrees. All right, so if I labeled this 0, this would be 180 degrees. I could label this let's say B is at 105, and let's say D is at 248, going around, okay? I'm just making that up, because 0 all the way back around to A would be how many degrees? 360 degrees, that's right. All right, I want us to look at something. The degree measure of an arc will always equal the measure of a central angle. So a central angle will always equal the measure of the intercepted arc. The degree measure of this intercepted arc. Got it? All right, now, what's the measure of arc AB? From A to B, yes. A is at 0, B is at 105, so what's the measure of the arc? It's 105 degrees. So then, we can know the measure of angle AXB. What's the measure of angle AXB? Anybody else other than David know? David knows. What's the answer?
105.
105 degrees. Because the measure of a central angle is always equal to the measure of its intercepted arc. If arc AB is 105 degrees of the circle, then that central angle is 105 degrees. Okay, what's the measure of arc CD?
105.
How'd you get that?
Vertical angles.
They're not vertical angles. How are we going to get the measure of arc CD? Landry?
Subtract 248 by 180.
That's correct. 248 minus 180, what is that? What is 248 minus 180?
68.
It's 14. Yeah, 68. 68 degrees. That's the measure. It's 68 degrees of the circle. Does that make sense? Okay. So, what is the measure of angle CXD? Yes, Landry?
68.
68 degrees. Why? Because the measure of a central angle whose vertex lies on the center is always going to equal the measure of its intercepted arc. Okay, look at your handout. Arcs and central angles. Now this is just going to help you, this first page, just understand the terminology. Look at number 1. We're going to name the arc that is associated to the angle that's given. Okay, so number 1, angle FQE. What arc does angle FQE intercept? Ari, what arc does FQE intercept? Arc FE. Arc FE. Got it? Okay, yes, arc FE.
Do we write out arc or is there a symbol that we use?
Okay, could I have said something different?
Yeah.
Okay, I could have said that. Could I have said something different? I could have said FDE. Why could I have said FDE? Is that not also angle FQE?
Because it's all the same circle.
It is the same angle. Angle FQE is a reflexive angle, meaning it's greater than 180 degrees. We're going to have angles greater than 180 degrees. We're going to have angles in the thousands. Eventually. Okay, but let's look at the obvious angle. All right, what about angle 1, Abby, for number 2? Angle 1, what arc does angle 1 intercept?
E. Wait.
Number 2,
Oh, sorry.
what?
No, I don't know why I wrote E. It's an H.
HI, that is correct. All right, number 3. Now we're going to name the central angle, and the arc is given. Alexis, what is the central angle? Angle 1. Everybody see that for number 3? You see how the arcs and the angles relate to each other. All right, number 4, Isabella. What is arc ML? What angle? Angle Q, but let's give it some 3 letters. Let's go angle MQL. Okay, now we're going to go both ways. All right, David, number 5. The arc is given, so we're asking for the angle. If the angle is given, it's asking for the arc. Got it?
Yep.
All right, so 5.
Angle RQS.
Angle RQS. Everybody got that? Okay, Landry. Major arc for angle 1.
Is it arc BA?
Yes. Arc BA. Is that a major angle? Is that the major arc? Is that major? What's a major arc? Over 180 degrees. So is arc AB or BA 180 degrees? More than it? No. Okay, so what's a major arc for angle 1?
Wait. Would like AC be one?
ACB, yes, ACB.
I said ACB one.
Did you say ACB first, at first?
No, I said AC. Would ACB or
He meant is
Would ACB
is arc
one?
AC.
I would say ACB.
okay. Wait.
ACB would be a major arc.
Okay, I was confused. I thought. Okay, so if it goes over, if it like starts at another angle, then you said one.
Well, this would be ACB plus angle 1 would be 360 degrees, right?
But what we would just say ACB.
ACB, yeah. Okay, 7, Chris. You have a question?
About number 6.
Yeah.
So it says greater, and then
Yeah, it's looking for a major arc. Major arcs have to be greater than
180.
180. The only major arc associated with angle 1 is ABC. It can't be AB. AB, that arc would equal angle 1, but a major arc associated with angle 1 is ACB, the other side. Has to be greater than 180.
Oh, okay.
All right, now can you do number 7? Angle KQL. KQL. What's the arc? Angle KQL.
KL.
Correct. 8. Jack.
Put an angle
SQ what?
T.
T is correct. Yes. All right, now we're going to actually find the measure of the central angle, Luke, for number 9. And the question mark is there. So we were either finding the angle or we're finding the measure of the arc. So Luke, number 9. What's the measure of that angle? 120 is correct. Number 10, Selby. What's the measure of the arc?
Wait, which one?
Number 10. The question, that little question mark, where that little question mark is.
123.
Yes. Okay, now the next page. A little harder.
Like
Yes. All right, Elliot. What's the measure? Now they've added the little m. All right, that means measure. That m means measure. What's the measure of arc CFD? I should draw this one. Do we have a diameter?
Yes.
We have a diameter. That's C to F. Do we only have one diameter? Do we only have one diameter?
EB.
EB is a diameter. Okay, I'm going to try to make it a diameter. EB. We have this is 135 degrees. Then we have D over here. And this is 81 degrees. Okay, so we want to go C around to F and to D. So everything but CD. All right, so how can we figure this out? Well, do we know what C to F is?
Yes.
What's C to F?
180 degrees.
All right, so then we can arrive at what angle?
The B.
This, or CB,
45.
okay? This is gonna be 45. This is 45. Do we have any vertical angles inside? The two diameters form vertical angles. So this is 45 degrees. All right, now, Elliot, what is CFD? I really don't know.
It would be 54.
No.
C
CFD,
to D is 54. Sorry. 306.
306. 306 degrees.
Close
Does,
on
does
that,
anybody
close.
else agree with that? I didn't do the math.
Yeah,
I
it
did-
is.
I calculated.
It's 180 and 45 and 81.
You were close to that first one. That was close.
Okay, Ethan, you get number 12. What's the measure of SPQ? And it's the angle. SPQ.
It'll just be arc SQ.
It would be arc SQ. All right, so it's this. Do you have it, Ethan?
Yeah.
Do you have the answer?
For what number?
For number 12. Angle SPQ.
I thought it was just.
Do you have an answer? A number. Degrees equals how many degrees? You're right, Landry. Has everybody worked this? We know Landry has. Yes, Elliot. Have y'all worked it? Luke, did you work it? Don't tell me the answer. Just did you work it?
No.
Work it. Figure it out.
Are the two angles equal?
Yes, they are marked to be equal. You don't even have to know that.
Yeah, it doesn't
Can I
matter.
real quick?
Is it 146?
So you don't have to.
It's 146.
Oh.
Okay, some of you may have found this angle. You know what I did? 360 minus 154 minus 60. Because it's everything else.
I just did.
Well,
I did it a little easier than that.
okay, what did you do?
I just did 360 minus 214.
Oh, you had already added them. Same thing.
Oh, I didn't. I thought you said.
360 minus 154 minus 60,
Oh.
which is the same thing.